Okay, so I have the vocabulary posted, but basically just a quick little snippet. A variable is a quantity that changes over time, right? And we usually use letters like X and Y are our favorite letters to represent a variable. But there's two different types of variables. So we have the independent variable and the dependent variable. And I want you to think about the independent variable as the determinator. So the independent variable determines what the other variable will do. Okay, like time is a great example for an independent variable because things change over time, right? Things grow over time, money grows over time, in a bank account, things like that. Also, number of items could be an independent variable. So, like, the number of jeans determines the amount you pay. The number of miles you drive determines the amount your rental car costs. Things like that. So the independent variable is the determinator. It is your X variable, your input. The dependent variable is what is your depends on variable. So the total cost depends on the number of things you buy. The total cost depends on the number of miles you drive. The total number of people depends on the number of tables you have, things like that. So that's going to be your Y value or your output. Okay, so we're going to think about the vending machine example from yesterday. And we're thinking about the fact that the type of drink you purchase depends on the button you push. So you would say that the buttons are the determinator, right? The buttons determine what type of drink. So that means that the buttons are the independent variable. And an independent variable in a function determines what happens to the other variable, okay? The button you push determines what kind of drink you get. Okay. All right, a little bit of matching here. So we have the word bank of vocabulary terms. We're just going to fill them in. So the amount of money, well, let's talk about the situation. So the fee to rent a van from Ralph's Rent-A-Car is 30 cents per mile, plus a one-time charge of $40. Answer the following questions about this relationship. Okay, so the amount of money being charged is a variable because it can change. The number of miles you drive is also a variable because it can change. Okay, the amount of money charged is the blank because it is calculated based on the number of miles driven. So the amount of money charged depends on. That means it's in a dependent variable. It depends on. Okay. The number of miles you drive is the determinator. So it is the independent variable. Okay. To make a graph of this relationship, you would plot the number of miles driven on the x-axis because that's your independent variable. And you would plot the amount of money charged on the y-axis because that's your dependent variable. Okay, is this function a relationship? Explain. Okay, so this kind of goes into what we did yesterday. So we can't just say no repeating x values. We have to talk about context. So yes, this relationship is a function. And we can say that every mileage is associated with a unique total cost. Okay, and all that means is that if you drive 5 miles, 6, 7, 8, 9, 10, however many miles you drive, there is a cost associated with that. And that cost is not going to change. If you drive a 10-mile trip on Monday, it's going to cost the same amount as if you drove a 10-mile trip on Tuesday. Okay, you're going to have a 10-mile trip cost a certain amount of money no matter what. That's not going to change. Okay, so this is just a little more in depth on the vocab. And then here's the meat of what we're doing today, and this is what your homework will go along with, okay? So we're considering the following situation. A restaurant is preparing for a banquet. We have square banquet tables. One person can be seated on each side, and the manager, as he's setting up the tables, like he pushes them together. Okay, so we have two variables. We have the number of people to be seated, and we have the number of tables. So we need to figure out which is the dependent variable, which is the independent variable. So who's the determinator and who's the depends on, okay? So the independent variable, and we've done table and people situations before, so you probably already know the answer to this, but the independent variable is going to be the number of tables, because that determines how many people can be seated. Okay, so our dependent is the number of people. Okay, and provide an explanation, short and sweet. The number of people seated depends on the number of tables. Okay, so we need to create an input-output table, and then we're going to graph it. We're going to write the rule. So let's start with our table. So our input is our independent variable. I goes with I, or in goes with in. And we said that that was the number of tables. Okay. And then our output, or our dependent variable, we said was the number of people. Okay. All right, so we can just look at this diagram to fill in the information here. So if we have 0 tables, we can't see that, so we can't answer that from our diagram, but we can tell if we have 1 table that fits 4 people, 2 tables fits 6 people, 3 tables fit 8 people, and we can continue this pattern on just to give ourselves some more points to plot. Okay, and hopefully you're seeing that the pattern here is +2, so we can go ahead and fill that in, 10, 12, 14, 16. Okay, all right, so we have this table, and we need to now write the rule. Okay, it's been a little bit since we've written the rule, so let me give the little Cliff's Notes version of it right here. M is your slope. Not your stope, your slope. And that is your change in y over your change in x. B is your y-intercept, and that is when x equals 0. Okay, so we're going to start by writing our skeleton, just like we always do. Okay, and then we're going to go through and we're going to find our change in y and our change in x. Okay, so our change in y, as we move through this table, is +2 all the way down. Our change in x, as we move through the table, is +1 all the way down. Okay, so then we take those two values and we divide them. 2 divided by 1 gives us 2. And that is our slope. Okay. Now we need to find our y-intercept. So we have to work backwards in this pattern to get our y-intercept. And if we work backwards in the pattern, we find that our y-intercept is 2. And we can go ahead and fill that in. to our rule. So our rule is y equals 2x plus 2. Now we have to create our graph. Okay, so we're going to create our graph. These are our checklists. We need to label our axis, we need to scale our axis, and we need to plot our points. All right, so our x-axis, we said in our table, our independent variable is the number of tables. We said our y-axis, or our y value, was the number of people. Okay, so we have labeled our axes. We need to now scale our axes. So we're counting by ones on the X column. So we can do that here. We have a lot of space though. Maybe we can yeah, we can count by ones. I'm not gonna label every one though. 1, 2, 3, 4, 5. I'm just gonna label the 5s. Oops. 2, 3, 4. Okay. 1, 2, 3, 4, 10, 15. And I know that we can't see all the way up to 25 in our actual table that we made, but we can probably extend the pattern. Okay, and let's see. I think we can probably count by ones as well on the y-axis. Remember, we just want to give ourselves a nice spread out picture. We don't want it smushed. And I can get all the way up to 35. Okay. All right, so we've scaled. Now we just need to plot our points. Okay, so we know we have 0, 2. So I'm going to plot that point. We have 1, 4. We have 2, 6. 3, 8. 4, 10. 5, 12. 6, 14, and if you see, we can keep extending this pattern even though our table doesn't go past 7. We're really just going up 2 over 1. So I can, from this point, I can go up 2 over 1 and extend, up 2 over 1, and extend it further, giving us more data and a better picture. Okay. All right, so I've plotted my points. I have 100% graph right here, and your homework question is very similar. You have another table and people situation, but it's a different situation. So use this as a guideline.